We will be presenting you with our capstone design project on developing an augmented reality system based on 3D user gaze tracking. Traditionally, the user interacts with the AR system through controllers. If the user is handicapped, the AR system would be inaccessible. Our team is motivated to overcome this problem by exploring alternative AR interfacing solutions, specifically through gaze tracking.
Our design is able to project virtual information right next to the object the user is looking at. And when the user moves gaze to another object, the virtual information changes accordingly.
The coordinates mapping module received both gaze vectors and 3D positions of the QR markers to identify which QR marker is under user's gaze. Finally, the render and display module projects corresponding virtual images to the user.
Our project goal was to develop an application for translating American Sign Language into English. There's a major communication gap between deaf people and the rest of society.
3 main stages: getting input from the camera into a usable format, processing it in the FPGA convolutional neural network, and outputting to the monitor. The average accuracy is 89.17%.
Now I will do the first gesture, which is hello. And then what? And then school.
The average prediction accuracy tested on 2 individuals is 92%.
Children with ASD often have an inherent difficulty recognizing facial expressions and vocal social cues.
Our solution is a web application that can be run locally on your computer. A user uploads a video of a person speaking, and with the click of a few buttons, our program breaks this up into different components of audio and visual data and analyzes these using machine learning. It then returns what emotion the person in the video is displaying.
We performed image-based prediction by leveraging leading cloud services provider AWS's recognition tool. For our audio prediction, we used an AlexNet-based transfer learning for feature extraction. We then used LightGBM to combine these predictions. LightGBM is a gradient-boosted decision tree framework, which trains a tree to make more accurate predictions from the inputs.
In this video clip, Aleksei says that he was trying to portray anger. So let's take a look at how our classification pipeline classifies this video. We see that the correct final classification was made as angry.
Our project is the HDL to Redstone compiler, an HDL compiler for Minecraft Redstone circuits. It takes HDL or hardware description language source files as an input, for example Verilog files, and produces a schematic file that can be loaded into Minecraft as a Redstone circuit. This is a 4-bit multiplier, this is a 1011 sequence detector, and this is a counter.
Right now we can see the output is 0. We can use this switch to start the counter. As you can see, the output is increasing. We just had 1, 2, now it's 3, 4. If we want to clear the counter, we can use this switch. Now the counter is zeroed.
Aphasia is a language impairment that is caused due to a neural stroke or a brain injury. If a person has aphasia, he is given a few weeks of intense speech therapy sessions.
Each word is represented by a vector in the multi-dimensional space. Image recognition gets the image and detects the object's name in the image. It then sends the name as a request to the dictionary API, where the output will be the cues that we are looking for here.
Let's begin the application. We first locate ourselves and identify it as a restaurant. As you can see, there are 4 cues and you can review one by one. Based on this information, you can select the word you think is correct. And great, we got it right! We can add new exercises by taking a picture. Here's an apple. The app automatically detects the object in the picture as an apple, and we can save it to the database.
PitchFix is a tool that has been designed to help users improve the quality of their speech conveniently from the comfort and privacy of their own homes. This tool focuses on improving vocal fry, monotony, and uptalk.
The application is made out of 2 major modules. The front end uses Pygame and SoarPy
to create an interface between the user and also the backend. The backend is made entirely in Python, and it also begins by calling the Google Speech API. They correlate the words that have been transcribed with the vocal issues that have been detected.
The project is able to record human frequency for analysis and detect intonation patterns.
Something that really irritates me, and that is vocal fry.
Has a 70% accuracy rate on all measured vocal misuses, and has a simple and accessible graphical user interface.
Our project is a walking acrobat. The goal of the design was to basically build a robot with 2 links and 1 motor that can basically move on a horizontal surface using the control algorithm that was provided by our professor.
So this is the robot. Now I'm just showcasing the microcontroller mounted inside. We're using Arduino Nano 3. This is the second IMU mounted on the lighter leg. Here is the first IMU mounted on the heavier side. This is the microcontroller, H-bridge, and also the motor.
So as you notice, when it's completed its bounce, there's a slight deformation of the leg. This deformation created the bounce and made it very difficult to walk. In order to address the bounce and slipping issue, an additional feature we have with the curves is to reduce the velocity of the impact with the ground.
Our project is called multi-hop networking with IoT devices, because all the nodes need to be within the range of the gateway. This network topology forms a tree structure, and the nodes no longer need to directly connect to the gateway. We have also considered the case where a node in the network failed, so we added a self-healing mechanism to tackle this problem.
It consists of e-byte LoRa transceiver and Arduino board that runs our program.
The first step is we will power up the gateway. So now the gateway is powered up. The next node we will turn on is A0, so we will turn on node A0. And then we will turn on node A1, which is right here. So node A1 is powered on. And then we will power node A2. So node A2 is not powered on. So now all 6 nodes are connected in a network.
We intended to design a motion planning subsystem for a self-driving car.
In the blue box, that is our lattice planner. That is the main brain of our motion planner. If there's an obstacle in front of us, we will prune off all the edges that collide with that obstacle. So if you see here, we're kind of driving towards this pylon in the middle of the road. And then as soon as we get close enough, we're going to say, okay, this pylon is still here, so we're going to adjust our path to go around it.
The velocity generator just kind of has 2 main basic layers. So the behavior layer, we go through the analytical layer, which kind of outputs a trajectory. So this is an actual velocity profile.
This shows the battery energy over time.
Have a dummy pedestrian on this side of the road. And then the idea is someone is going to pull it with a rope. And as you can see, our car successfully stopped.
The topic of our project is crowd characterization by the processing of video signals. Our goal was to develop an accurate video processing software that is able to detect the individuals that appear in the video.
As the video progresses, information about the crowd is being updated in the bottom left. These green boxes around the person actually represents a person that was detected. In the biker's case, we could see that their face was picked up. They were predicted as a male within the age range of 21 to 53. So the specific facial detector we're using is called a multitask cascaded convolutional neural network. And so for the gender and age detection, we're actually using 2 pre-trained deep neural networks that actually come packaged with the OpenCV library.
Prosopagnosia is commonly known as face blindness.
Our team is motivated and inspired to develop a wearable human-centered system. This app recognizes faces in the database through the camera in real time using an open-sourced online face recognition library.
The real-time mode is able to detect the person that has been added from previous usage.
Hello, Angel.
Hi,
David.
Similarly, if the person does not exist in the data record, ECE will prompt as unknown.
Hi, Melissa. Nice
This is unknown.
Hi, Melissa. Hi.
The user is able to add contact after the conversation. Click the Add button to start the adding procedure. The user is able to select Add New Person option and enter the name of the new contact. Another feature is that ECE can recognize multiple faces simultaneously. The at-home training mode is a standalone mode. In each round, ECE displays the name of the person to be identified with 9 other random contacts. If the wrong picture is selected, then the correct image will pop up for the user to learn by naming 3 obvious feature characteristics.